Thank you. So I wondered actually about what to talk in the summer school. Actually, my initial intention was to talk about completely different subject, which is a couple of papers, actually 3 papers that I wrote recently with Michael Richter. Those of you who are interested, I, of course, can read them from our website. But because of some personal reasons, I just did not finish the show. So the show was not ready. So instead, I presented one paper on the first presentation was completely independent from the second one. The first was a new paper. The second, actually, I picked a paper which, what I can say about it, that out of the papers that I was involved, let's say, in the last 10 years, that's the paper that I like most. So that's the paper. Okay, so that's a joint paper with Jacob Kobi Glaser. He's somebody that is a person from Tel Aviv that I was working with a lot in the last 15 years, mostly, not only, but mostly on persuasion models. Persuasion models that has nothing to do with Bayesian persuasion, no Bayesian at all, not at all, but there is persuasion beyond Bayesian. And here is one example of this work. Those of you who don't know Jacobs or Kobe, you will see him here, of course. And that's again in our lab in Tel Aviv. That's another lab where actually near this table, more or less, actually the main idea of this paper was created. I will start with 2 examples. Which just to put you into the mood. It's not introduction. I hate conclusions, and I also hate introductions. So that's not introduction. It's just to put you into the mood of the paper. Okay? So relax, and scenario A. That's a true scenario. After actually one of the first presentations of my paper, of this paper, MR, a very intelligent guy, he has a PhD in economics, was in Israel, he was in Tel Aviv, and he sent me more or less the following email. I went to a bar, and I was told it was full. I asked the bar hostess what time one should arrive in order to get in. I was told by 12, of course, 12 midnight. And once the bar is full, you can only get in if you are meeting a friend who is already inside. I lied that my friend was already inside. Without being told, I would not have known which of the possible lies to tell in order to get in. So let's analyze this very realistic. So that paper is about life, real life. That's the scenarios that we are interested. Let's analyze the structure of this very simple situation. In this situation, there are 2 agents. One is MR, and one is the bar owner or the bar hostess. And the problem of the bar hostess or the bar owner or whatever is that they don't want everybody to get into the bar. MR wants whatever are the circumstances, whatever he knows about himself, and he knows about himself everything, wants to get into the bar. The bar hostess wants to let MR in only under some conditions. And now add to the story the constraint, which might be legal or might be custom or might be just kind people, that actually they cannot just, like many selectors in bars, you must know it better than me. You go to the bar, there is some selector, you say yes, no, yes, no, yes, no. No, here actually, that's Israel is a very, very organized country. I'm joking. So you must also give a reason to why yes, no, yes, no. You have actually to announce what is the rule for the selection, and she announces the rule of the selection. So she must announce the rules of selection before the information is received by MR. Now, MR faced a problem. He wanted to get in independently of whether he had a friend inside or not. The truth is that he did not have a friend inside, a lonely guy in Tel Aviv. But he wants to get into the bar. But he still wanted to get in. He faced the following very complicated problem: what to say in order to get in. He was intelligent enough to solve the riddle and to know what he should say. I should also add that he did not have any restrictions. He did not have any disutility from lying. This is not a situation that you feel obliged to say the truth. And as he said, he lied that my friend was already inside. No friend and no inside, and he was in. So the situation was, in some sense, is what we will call persuasion situation. He had actually to persuade the hostess that he has the right, or he should actually get into the bar. The rules, what can persuade the hostess, were public, and he did succeed to solve the riddle and to say the right things in order to get in. In this respect, actually, this mechanism of persuasion that was announced by the bar hostess did not work well. It would work if people would say the truth. It would not work well if they are intelligent enough to manipulate what they're saying. Okay? That's scenario A real scenario. In some sense, the paper is in situations of this structure, but scenario B will be actually a better getting into the mood than scenario A. That's not a real story. But as a background, let me just remind you, many of you know about economists from Berkeley with the name Shachar Kariv. And Shachar Kariv at least claims that he ran, I mean, I'm sure that he ran a very extensive experiment in the Netherlands. And his finding, so he claims, that people who are more transitive are more successful in life. Believe it or not, that's his claim. Believe it or not, but our employer, the principal in the story here, does believe Shachar Kariv. And he wants, actually, his goal is to hire only people who are transitive. Okay? And the exact story is the following. As a part of the search process for a candidate for a particular job, a principal, namely the employer, wishes to identify those individuals whose preferences over the set of objects A, B, C is transitive. Transitive are the good guys. They will succeed. Intransitivity, because of Shachar Kariv, we know they are bad guys, should go out, should be rejected. Each individual has to answer 3 questions of the form. How do you compare the objects X and Y? So there are 3 questions. How do you compare A and B? How do you compare B and C? How do you compare A and C? And the options are just 2. There is no indifference here. You must say you prefer one of the 2 possibilities. Clear? So the questionnaire includes 3 questions. Each question is binary, and you must answer. It's a quiz question with 2 options. Clear? Okay. Now, but recall that actually we are under the condition that law or whatever requires, and probably not just requires, probably as you will see, actually it will play an important role, that the employer will announce the conditions under which the candidate will be accepted to the job. He has to announce it. But there are many ways to announce it. And now we come to the notion of framing. And the framing that we are going to explore are framing that we call it a codex. It looks terrible, but let's see what is going on here. So there are actually, each of the lines, each of the sentences, we call it a rule. So there are 4 rules in this codex. And again, the interpretation of this codex is, he is a candidate. I tell him, you should answer the 3 questions, and you can know, that you will be accepted to the job if your answers will be such that they will satisfy all the 4 rules in the codex. If one of the rules fails, then you are out. If your answers satisfy all the 4, you are in. Clear? Now, to make it realistic, think about the situation also as a situation where you are under some time pressure. It's not probably 5 seconds, but you have some time pressure. It's not that you can take this home and come in the next day and give the results. And I guess that everybody would solve the riddle. But in this case, but think about it that you are under some pressure. What do you do? Well, let me, before we get into, just to speed up the discussion, now it's a discussion between you and me. The subject, the candidate, does not, now is not aware of the discussion that we are now having. So let's try to understand actually what's the meaning of these 4 rules. So the first 2 rules are very clear. They say actually that your answers should not have a cycle. If you say that you prefer, there are 2 possible cycles. So if you prefer A to B and B to C, you should also say that you prefer A to C and the other cycle. That's clear. And these are actually remember that actually these are the guys that satisfy these 2 conditions. These are the guys that I want to hire. However, surprise, surprise, in this codex there are also 2 other rules, which looks a bit more bizarre. And the other rules are, if you prefer A to B and A to C, you should say also that you prefer C to B. And if you prefer C to A and C to B, then you should say also that you prefer A to B. Explanation in words of human beings. What actually R3 and R4, R1 and R2 says that your answer should be transitive. R3 and R4 says that the B should not be in the middle. Namely, because if A is on top, then C should be better than B, so B should be the last. And if C is on top, then A should be above B, so B should be last. So that's actually the interpretation, therefore, is that B should not be in the middle. Clear? But that's something that between you and me, it's not between the principal and the agent. The principal chooses to present the rules that we interpret as you should have preferences which are transitive and B are not in the middle, that's our interpretation. The candidate just see the 4 rules. Clear? Okay. And now we come to what we are. That's a model about, as you've seen in the title, it's a model about persuasion with bounded rationality. Now, what is bounded rationality? It was a subject for quite a hot debate in the last 10, 15 years. There are people who have different definitions. My definition of bounded rationality is that it's a model which contains explicitly reference to the procedure of decision making. It explicitly contains, the language of the model contains explicit reference to the process of decision making. In this respect, for example, Rani's work is a very clear work of bounded rationality. And this work will be a work of bounded rationality because I'm going now to very explicit assume some assumptions about how an agent, a candidate to the job in this case, solves this riddle. So it's not a standard choice problem of the type of, it's more sort of a puzzle or riddle that he has to choose. The utility is 1 if you solve and 0 if not. It's very nothing to say about it. But the question is whether I can find the action or the action that will make me actually getting the 1, namely getting the job. And now comes a suggestion for a procedure. And the suggestion of the procedure is not apology. Let me say immediately, there are many procedures that I can think about. This is one particular one. In the end, in the last 10 minutes, I will present some experimental data that I will claim that support the particular procedure that we are analyzing in this paper. But we don't have any, we are not religious about this procedure as you have some other procedure in mind, another procedure, another paper. That's all. Okay, so the procedure that we are analyzing here is the following. Here is the clever man. He's on the right. He's a candidate. Let's say that his real preferences are BAC. He's a good guy. He has preferences which are transitive. He should be admitted. What does he do? Our assumption is, our assumptions are that the first thing that you do is you check, you don't lie unless, it's not because of this utility of lying, But the first thing that comes to your mind, when I ask you any question about yourself is, first of all, if you know the truth, is to say the truth. You might actually lie because if there is some reason, but the anchor to your thinking is the truth. In this case, B prefer to A to prefer to C. The guy does not have any reason to lie. He checks the 4 rules. He sees that actually all the 4 are satisfied by saying the truth. So our assumption is that he will say the truth, and he is inside, he gets the job. Clear? Now, he's another good guy. He has also transitive preferences. But this time, the B is inside. He now looks at R1 and R2 are satisfied. R3 and R4, R4 does, because the antecedent is not satisfied. R3 is not satisfied because indeed A is preferred by him to B and A is preferred to C, but it's not true that C is preferred to B. Now the question, so up to now, our assumption is that first of all, he checks the truth. He checks, and rightly so, if he does not make mistakes, discover that R3 is false. R3 is false, but he wants the job. What does he do? Our assumption here now that in this case, at least he tries to cheat through just changing the consequent of the rule that is not satisfied. So instead of saying that he prefers indeed B to C, he knows that if he say B to C, he will fail R3 and will not get the job. So our assumption is that he keep the antecedent assumptions, but he just changed the consequence and is going to say that he prefers C to B. This will lead him to behave as if his preferences are A, C, B. And we have seen already is that, of course, if he will behave as if his preferences are A, C, B, he will get the job. So our assumption is that our candidates are intelligent enough, they have the cognitive ability to do this particular type of exercises. Good. So if indeed they are able to do it, then this good guy, although he cannot say the truth, will cheat, but he will get the job as we wish it to be. But now, what's about now? Assume that this candidate is a bad guy. He has a cycle. Now, the question, of course, now he's checking and he's observing that actually R1 is not satisfied. He prefers A to B, B to C, but he does not satisfy A to C. If he follows the procedure that we have just described, and that will be our assumption, that this will lead him to behave as his preferences are A, B, C. But if he will behave, his responses will be according to A, B, C, he will fail. So what will he do in this case? He will try actually probably to make another change in his preferences. Maybe that there is more than one rule that is not satisfied, and he will go back to the truth, he will try to modify it a little bit in another direction. In this case, actually, there is no other int, and our assumption will be, in this case, that he will just give up, either say the truth or will just burst in tears, and that's the end of the story. In any case, our assumption is not that he will follow another procedure, and of course, there are many procedures that would lead him to solve the riddle. So the procedure that we are going to assume, so we are going to talk about situations where the principal will suggest the rule of behavior, the rule of what will persuade me, will be actually a questionnaire of this type. The principal is aware of the cognitive limitations of the agents, and he will try to compose such a questionnaire that will separate between the good and the bad guys. Let's see it more precisely. So first of all, let me, before I get into the formal definitions, what is the procedure that we have essentially in mind? There is essentially here because of something that you will see later. But essentially what we have in mind is the following. When an agent has to solve a questionnaire of the types that we have just described, namely a riddle of this type. And again, what is a riddle? It's a set of sentences of the type if blah, 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 then, if blah, 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 then, and so on. And then, first of all, he examined whether the true profile, by profile I mean the story of life, the facts which are relevant to the situation, whether it's saying the truth satisfies the codex. If it does, then declare happily the truth, and you are fine. If not, go to step 2. Step two is the step of trying to cheat. But you don't check all the possible cheating possibilities, but you find a rule that is violated by your true profile, i.e. your true profile satisfies the antecedent but not the consequent. Then change the consequent and check whether the modified profile satisfies the codex. If it does, declare the false profile or behave according to the false profile, and if not, iterate step 2 until you are starting again, but that's important, starting again with the new profile. So it's not that you are alpha, and now after changing yourself, the story, you go to beta, and then from beta you go to gamma, but you go to beta, you go back to alpha. You go to gamma, you go back to alpha. The anchor is your personality, your personal story that is very deeply inside your mind. And if you exhaust step 2, then declare unhappily your own profile and give up. That's basically the procedure that we have in mind. Now, models of bounded rationality, I think that most of us, when we work on models of bounded rationality, then we have in mind, at least I can speak about myself, usually I am not so much interested in the situation, the economic situation. It's not coming from economic intuition, it's coming from modeling challenge. So we want to actually to put such a situation inside economic model. And since we work indeed on some models of persuasion and non-Bayesian persuasion, of course, as I've said before, then we found it, but it's not necessary to try to embed such a procedure into an economic story of the type of persuasion. Now, basically, and of course that's connected also with implementation theory. And the implementation theory, as you know, then the assumption is in all this almost all this literature is that cheating is easy and costless, and people do it. There is some literature, mainly work by Kretik, Nevin Kretik. Also there is some work of Kobe and me in the past that we were talking about cheating is limited, or that cheating is costly. But our approach in this paper is different. Namely, we are assuming that the ability to cheat effectively, it's not just to cheat, but to cheat effectively, namely to solve the riddle, namely to say the right things, depends on the way that the mechanism is constructed and framed, and depends about who you are. As I've said, we are talking about persuasion, or, well, what we have in mind. This is for business school type of audience. You are not, so we can skip on that. So there is a speaker and the listener. The speaker knows something which is relevant for the listener. The listener wants to be persuaded under some circumstances, and does not want to be persuaded under some other. So that's a very typical economic situation. There is some conflict of interest, and there is some common interest. And what we have in mind is a situation like that. The speaker speaks. There is no possibility for the listener to verify the information. If it does, it's very interesting, but it's not for us. That's a situation that the only possibility is that the speaker speaks. All the speakers can say the same things, unlike in previous works that we have done. But nevertheless, the listener wants to accept some of the guys and to reject some other. Actually, I've said it already. A speaker, the listener, and this situation, of course, situations like that could be analyzed in two ways. Somehow, and I don't know why, much of the literature analyzes situations like that as a game. We preferred to think about it, but of course it's not impossible, but we prefer to think about it completely. That's actually the only use of the word game that I will use is to say that that's not a game. We think about it as leader-follower scenario. Of course, you can say that it's an extensive game, but that's nonsense. We think about it as a sort of a Stackelberg leader-follower scenario. So the situation is the following. The listener commits to a persuasion rule. And persuasion rule in this case is a set of conditions, a codex, that the profile presented. And the agent will have, after that, will have to present some profile, namely will have to tell the story of his life. The meaning of the persuasion rule is that that's a commitment, that if your statement will satisfy the conditions, you are in, you persuade me, and if not, you fail. So the listener commits and announces the codex, like the hostess of the bar does. The speaker announces a profile, and then the listener applies the persuasion rule. So the step 3 is not strategic. It does not imply any Bayesian thinking here. He just commits. He just executes what he announced in stage 1. Clear? There is one. Now, if the situation would be without bounded rationality, then this is the most stupid situation that we can think about, because of course the speaker will just solve if there is any solution, he will find it. And if there is no solution, so why to start with this at all? And there is no possibility to separate between the good and the bad. However, there is a small problem, and which is not small problem, without it there was no paper, which is that the speaker is boundedly rational. In boundedly rational, again, it will be in the sense, before we come to the model itself, it will be in the sense that I've described before, have in mind that he has ability to try to find the solution to the riddle following the procedure that basically I've described before. Okay. A model. So the model is a bit not non-standard. So therefore, I will spend most of the time probably to present the model. And then we'll talk about, of course, some of the results. But let's speak about the model in details. So we need a model where actually there will be a possibility to talk about statements, riddles of the types that I've just described. And here it comes. So first of all, we have a set. The set V is a set of. Formally, it's a set of propositional variables in the language of mathematical logic, but it's not necessary to think about it. You don't need to do any mathematical logic for this paper. The idea is that V1 and Vk are K facts which are relevant to the story. K facts about yourself. You are a male or female, you have glasses or not, you are bald or not, you have a black shirt or white shirt, etc., etc. These are the facts which are relevant. And these are propositional variables, namely they can get only 2 values, either true or false. What is a profile? Again, a profile is a nickname that we gave here to your story of life. The story which is, of course, relevant to the situation. And this is the truth assignment. Formally, it's the truth assignment for each of the variables. S is the set of the stories. Namely, and now here is the assumption, which is that actually all the profiles, there are 2 to the power k possible stories of life here. We assume that all of them are possible. Notice that in some cases, this will not be the case. For example, if V1 is a male and V2 is a female, then etc. But here we assume that we are in a world where all the combinations, there are no logical contradictions in the variables themselves, and all the 2 to the power k stories in principle are feasible. Okay? That's clear? So k facts and a story of life is V1 and not V2 and not V3 and yes V4 and so on. Okay. Now, what is a codex? So a codex is First of all, a codex is a set of propositions in propositional logics, what we call rules, that uses only the variables in V, namely only the facts that we are saying that are relevant to the story. And again, this is just a repetition, that the idea will be that there will be a codex and the agent will have to say, to make a statement about who is he or she, and then just the principal will check whether the announcement, whether the assignment of, so a profile is assignment of truth values, and he will check whether the assignment satisfies or not the codex. According to that, he is persuaded or not. But we are going to make some assumptions about the codexes. We don't allow all codexes. And let me explain a little bit what are First of all, we don't want to include in the codex statement like V1 and not V2. Why? Because this actually will bring us back to the story in the bar of MR. Actually, if it would be V1 and not V2, then you are able, our assumption is that if I tell you what to say, then you say, like in the story of MR in the bar. So we want it to be of a different structure, and the structure that we allow here is that it must be that all the sentences, all the propositions in the codex are of the type, examples are better here than the general statement, of the type V4 and not V1 implies V3. Namely, it's a conjunction of variables or negation of variables implies either a variable or a negation of the variable, and the variable on the consequent should be different than the one of those that are in the antecedent. So therefore, V4 and V1 implying not V1 is not allowed. It's not a rule that we allow. Why? Because I think that it does not make any sense. So that's what we call the structural restriction. We are making also, it's not necessary, but I think that to make the analysis interesting, and also because we find it more reasonable, we call it a coherence. And now what is coherence? Coherence is that, again, look at the examples. We don't allow that the codex will include both V1 implies V3 and V1 implies not V3. More generally, we don't allow that there will be two propositions such that the antecedents are not contradicting, and one of them leads to confirmation of the variable, and one of them to the negation of the variable. Why that? Well, again, we just don't find such codexes nice, because I think if that's the case, if I tell you something like, if you are, who is allowed to be here? If you are if you are from Singapore, you should be economist. If you are from Singapore, you should not be economist. Then a guy from Singapore would come and tell and complain on INCO, what's the nonsense? What do you want from me? Something like that. So we don't want, of course, logically, it is equivalent to not V1, right? But we don't want to allow not V1, because then people will say that they are not from Singapore. But right? So, but in any case, such things we don't allow. We also don't allow V1 implies V3 and V2 implies not V3. So we don't allow that we'll say that if you are from Korea, you should have a position in Urbana-Champaign, and if you are a male, then you should not have a position in Urbana-Champaign, because then INCO will come and complain what you want for my life. So again, actually, the formal definition of coherence is that should not be two statements in the codex such that the antecedents are not contradicting, but the consequents are. Okay? You will see later what's the role that it will play in the analysis. Okay. Now, lambda is always a letter here for a codex. Codex, again, it's a list of propositions. Now, what is T of lambda? T of lambda, these are the solutions to the riddle. Namely, these are the profiles that satisfy all the all the propositions in the codex. So for example, if the codex is Vy implies V3 and V2 implies V3, if this is the codex, and there are three variables, V1, V2, and V3, then the solutions are listed here. They are listed, of course, in the language of 0, 1, natural identification of 1 with truth and 0 with false. And you see, in this case, there are 5 solutions to this codex. Okay. Now, actually, we come to the main point, the challenge of the modeling. There is a language now to say what is. We have now a language for both the codex and for the actions of the agents of the whoever is the whatever it is, a worker or whatever, a candidate to a job or whatever. Now, what we want actually is to formulate the procedure that the agent will follow. And the following is definitions that we find convenient to formalize the procedure. But again, what we have in mind is exactly the procedures that we described before. But let's go through this formalism. So given lambda, we are saying that the speaker is guided from S to S prime. So S is the truth. S prime is something that you will try. So now we come actually to define, given a lambda, given a codex, and given that the truth about you is S, and therefore this is the anchor for the procedure, what are the profiles that you will try during the procedure that you try to solve the riddle? And again, probably it will be better. I will keep it here and just to explain it through an example. Let's say that V1, the codex is V1 implies not V3, and V2 implies not V4. And let's say that, of course, there are 4 variables. And let's say that S is 1, 1, 1, 1. And now, of course, 1, 1, 1, 1 does not satisfy this codex. It violates both rules. But 1, 1, 1, 1 there are some profiles that are guided from this S to them. And what are they? There are the 4. Formally, it will be also 1, 1, the S itself, which in some sense it's a trivial, degenerate case. But it will be, for example, it will be 1, 1, 0, 1. Why you are guided from the codex from 1, 1, 1, 1 to 1, 1, 0, 1? Because you notice that a 1, 1, 1, 1 does not satisfy the codex. It violates, for example, the first rule. So this gives you an hint to try to change V3 from truth to false. So therefore, it moves you from 1, 1, 1, 1 to 1, 1, 0, 1. And the same thing, it also guides you to try 1, 1, 1, 0. But we are also assuming, and that's actually the essential point that we talked about before, we are allowing also that you will make 2 changes, 2 bits, but the 2 bits has to be justified by the bits that you don't change. Namely, I can imply, we do allow that the agent will say, okay, I keep the V1 and V2, the 1, 1, and I change simultaneously, not sequentially, this is a different story, but simultaneously I change both V3 and V4. We do allow it. It's not, again, actually it's not necessary and the results will be the same if we would allow only change of 1 bit, but we do allow in this presentation, we do allow that you will make more than 1 bit, but the justification, and justification means what? That there is a rule such that the variables in the antecedent are not changed from what you start and what you move to, that leads you, that justify the switch of the consequent. Okay? So if you understand that, actually the formal definition here is not very important. Let's read it. Given lambda, the speaker is guided from S to S prime, and it's denoted by this arrow. If for every V, namely for every variable, such that S prime V is different than SV, namely every variable that I change the assignment, the truth assignment, there is some sentence such that S and S prime satisfy the antecedent, but S does not satisfy the consequent, and S prime does. So that's actually just another way to say exactly what I said before. So this relation is extremely important. You have the lambda, but the lambda induces a relation from what S will try what S primes. Clear? Yes. Right.
Because that matters with the combining.
Because?
It matters with the combination.
Yeah, we don't allow. That's, yeah.
It's possible that the speaker is guided from S to 1 or 1.
From S to 1. No, because there is no justification. There is no, to move to change the V2 from 1 to 0, you need that there will be some sentence for which actually that the consequence should be not V2. So there is nothing like that. So you don't get the hint to change V2.
We can look at several codecs at the same time.
Sorry?
No,
always there is, the story is that the principal announced one codex. You can look at several rules, several sentences, but you have one codex in face of you, okay? And now we come actually to the main definitions. As you see, the model is very simple, but it's not very standard. And that's the definition that we call it implementation and truthful implementation. Now, let me back for a second. So there is a set S of profiles. What is the goal of the principle? A goal of the principle in this literature is some subset of agents. We denote them by the capital A for acceptance that I want to accept. I want to be persuaded by. The residual set, namely the S minus A, we denote it by R for rejection. So again, S is partitioned into good guys in A and bad guys in R. Now, what is implementation here? Implementation here is given, and of course, implementation given the procedure of behavior for the individual, for the agent, is such a codex, that's the only thing that the principal can do here, such a codex, such that the good guy will solve it. What does it mean the good guys will solve it? The good guys, namely, the good guys will solve it, it must be that if S is a good guy, then there is some S prime, which is in T lambda, namely it's a solution, such that S is guided by the codex to S prime. That's sorry. So the good guys can solve it, and the bad guys are not. Namely, for every S in R, there is no S prime that is guided to such that S prime is the solution to the codex. So in words, the codex is good if it separates between the good and the bad in the sense that the good, under our assumption about the procedure of solving the riddle, will succeed and the bad guys will fail. Notice that unlike in the literature, we have in economics a lot of literature of separation, all the literature Spence and so on. But in this case, actually, there is no there is no differences of the type that we usually talk about in separation. The differences are only due. All the agents are the same. All of them want to get the job. The difference is between the agents is only by the truth, which is actually allows any separation only because the procedure takes the truth as an anchor. If the procedure that people would use would be independent of the truth, then of course this would not be possible. So the idea here is to utilize the fact that the procedure is bounded, the agents are boundedly rational, but the procedure does depend on the truth in order to create this separation. Now, we have also the notion of truthful implementation, and truthful implementation is that the good guys not only can solve the problem, but they don't have to cheat. The bad guys are ready to cheat, but they are not able to solve the. In the implementation, actually cheating might be a good thing. A good thing because it might be that actually the principal wants some of the agents, the good guys, to cheat, because otherwise actually it cannot, maybe that he cannot create such a codex such that without, and you will see examples later, that without cheating he will implement. Now notice also that we talk here about, we are 0-1 guys here, namely we don't ask ourselves what is the probability or what is the number of states, number of profiles that will get the right treatment or whatever. We are just looking here at the question, what we are going to analyze is the question, what are the sets A, what are the sets A for which are implementable, and what are the sets A which are truthful implementable? That this will be the question that we will ask. Okay? Of course, you can ask the question for those which are not implementable, what is in some sense the optimal mechanism, but that's not a question that we analyze here. Questions? Examples. So let me go through 2 or 3 examples because I know that from my experience that they are necessary in this stage. This is the case, the following case. There are 3 variables, and the principal wants to have actually people who are consistent. I hate the people that sometimes are left and sometimes are right. I like only people that are always left or always right. I ask them 3 questions, and what I expect is consistency in the sense that they will give me the same type of answers to the 3 questions. Okay? That's actually behind the scenes. And now I will show you 3 codexes. The codex number 1 on the left side is V1, you see it, it's this one. Look at it for a second. Actually, it's very trivial. In words, what it means is the following. Take the first and the third line. It says that actually the second answer should be like the first. And the second and the fourth line says that the third answer should be like the first. Everybody here, I'm sure, understands that this means that you should give actually 3 identical answers, either 1, 1, 1 or 0, 0, 0. Right? Okay. Now, what are the solutions? So the solutions are indeed the 1, 1, 1 and the 0, 0, 0. Anything else will violate one of the 4 statements. Now, P, I didn't mention it, but what is P of lambda? P of lambda is actually the guys that will succeed if they use the procedures that we describe, will find the light, will solve the riddle. Who are the guys here? Everybody. Why everybody? Because, for example, let's say that the truth about you that you are not leftish or rightish always. You are 1, 0, 0. But for 1, 0, 0, you can use the first and the second lines to be guided from 1, 0, 0 to 1, 1, 1. If you're 1, 1, 0, then of course you can use. If you're 1, 1, 0. Then you will use only the second line to go from 1, 1, 0 to 1, 1, 1, and so on. So everybody can use, because everybody here can understand actually basically that the second answer should be like the first, the third like the first. Clear? Okay. Very bad. That's not what we want. Now let's look at the second. The second is a bit better. Look at it for a second. It says in words the following. The second answer should be like the first. The third should be like the second. The second like the first, the 2 lines. the third and the fourth says that the third answer should be like the second, right? But now not everybody can solve it. Why? Because if you are 110, you will solve it. 110, you will use the third line to move to, you're guided to 111. But if you are 100, then this allows you only, it guides you only to 110. You are stuck. It's not good. You go back to 100, and actually you have nothing else to be guided to. If you would continue for 110, of course, you will get to 111, but that's essentially here, you don't do 2 steps. You do only 1. So in this case, actually, all the 6 states, all these 6 profiles, besides the 2 here, will succeed to solve the riddle. And that's, again, it's better, but it's still not good. Yeah.
So you got this restriction, like you see, from alpha to beta, and then you go from alpha to gamma.
All right.
If you allow alpha, beta, gamma, is that equivalent to saying you can line any way possible?
No, you will come to it. You will come to it. We'll come to it in a few minutes. Okay. No. But now is there a possibility to implement this set A? Again, A is 111 and 000. The answer is yes. Then hold your breath. Here it is. Terrible. It's on the left. This does the job. This six propositions. This codex does the job. But now it will be very convenient for me actually to don't look at the left, look on the right, because on the right actually we will actually understand now the connection. Now basically what we are going to do now in the analysis is we are going to move from the language of logic to the language of graphs, of graph theory. And the way that we do it is the following. We take actually each of the profiles we identify with a node. There are, in this case, there are 8 nodes. These are the good guys, symboled in red. These are the bad guys. Now, what this strange codex does is actually the following. Take not V1 and V2 implies V3. What does it do? This codex, this does actually 2 things. This line kills the 0, 1, 0. 0, 1, 0, if it says the truth, will fail. But any case that I kill somebody, I also give him some way to be saved, in a sense, because I guide him to something else. So 0, 1, 0 fails, but is guided also to 0, 1, 1. That's clear? Now, it will be a key in the continuation. A proposition of this type, we call it a complete proposition. Complete because all the k variables appear in the statement. K minus 1 in the antecedent and the last one in the consequent. Now, each sentence of this type kills exactly one profile and guides him to exactly another profile, which is also, in the language of graph theory, it will be his neighbor. Neighbor in the sense that it's only the change is only in 1 bit in the profile. So now look back into the cube. This sentence is parallel, actually fits to the fact that we kill this guy and guide him to this guy. And now, what's the meaning of this codex? I kill this guy, guide him to him. I kill this guy and guide him to it. I kill this and so on, and I go back. So what we created here actually is a cycle of bad guys. Each of them is killed by being guided to a neighbor of him. But we succeed to have a cycle so that the good guys actually this is not only implementation, but it's a truthful implementation because the good guys actually here does not have to cheat. Notice, by the way, Vijay, that here actually, even if these guys continue and do many iterations of this process, it's a vicious circle of lies or something like that. Right? They will come back, they will not find the light. And that's actually the idea of this construction. Okay? That's another example. In this case, actually, I do like people who are decisive. So I ask a person, do you like to go to a Chinese restaurant? Do you like to go to a Mexican restaurant, to an Indian restaurant? I don't want to deal with people deal with people who don't have a clear idea what they want. So 110 is bad, 000 I don't like. Also, I like only the people who are decisive. I don't care about what restaurant to go, but I wouldn't want them to be clear about it. Okay? That's the logic behind this story behind this example. Okay, but that's not important. And now this is an example of something that cannot be implementable. And let me prove to you that it cannot be implementable. There is no codex such that, etc. By the way, look at this picture and just be impressed by it. There is something that you will see later. You see that the good guys here are in some, there is some, you see something, some structure. It's not coincidence that it cannot be implemented. But let's prove it. So there are two possibilities. Case one is that the implementation is done by truthful. Truthful implementation, namely the lambda is such that actually it defines the set of the good guys. They don't have to cheat, and the bad guys somehow don't succeed to cheat. So who is a bad guy? For example, a bad guy is the all false, is the 000. So we have to kill him. We have to kill him. How can we kill him? We can kill him only by having, up to permutation, a statement of the type not V1 implies V3, or not V1 and not V2 implies V3. Right? That's the only way to kill 000. Clear? Up to, of course, permutation. So one of them must be in lambda. Otherwise, it will not be implementation because this guy will say the truth and is in. So therefore, it must be that he is killed. But as I've said before, if he is killed, one of the two statements are in lambda, but therefore in each of them, if one of them is in lambda, then this means that 000 is guided either by the first or by the second to 001. But 001 is a good guy. And 001, we are in the case one, where T of lambda equal lambda, namely, if you say the truth is fine, it's truthful implementation, and therefore, so you are guided to a solution that's bad. You will succeed to cheat. Case one. Case two, the implementation is not with truthful, but without truthful implementation. So, without truthful implementation, namely one of the good guys has to cheat. Without loss of generality, call him 001. He has to cheat. He has to cheat, but he has to cheat because he is not a solution. He's not a solution, but he has to cheat. He has to be guided. Not only he has to cheat, he has to be guided to a solution. So it must be without loss of generality that 010 is directed, is guided into 010. Now, how 001 can be directed to 010? It must include, the only thing that is fixed between 001 and 010 is V1. So it must be that there exists, actually it must be also that, it must be that not V1 implies V2 is one of the propositions in lambda. Actually, it should be also not V1 implies not V3, but that's not important. Important is not V1 implies V2 must be in lambda, right? But if that's the case, again, our dear 000, who is actually here bounded by the good guys, he also, in this case, will be guided also to 010. And that's not good, because he should not be guided to a solution. Therefore, conclusion, this is an example of a set that could not be implementable, neither by truthful implementation nor by another type of implementation. Clear? Okay. I'm really slow. So let me rush to results. Let me also probably only say the following. Notice again that any complete statement kills one of the profiles and guides it to a neighbor. And also, of course, notice that if you have two neighbors like 110 and 100, of course, there is some way that I can kill the 110 and guide him to his neighbor, and that's, of course, in this case, it will be V1 and not V3, implies not V2. It kills the S and guides him to the neighbor S prime. So always we can do it. Okay, truthful implementation. So truthful implementation. So again, what can be done now? After we understand the model, what we can do is actually, I think the only thing we can do here is to, so it's not the only, but the main thing that we can do is really characterize the sets A, which are truthful implemented, and they are implemented without truthfulness. So let's start with the truthful implementation. Proposition. A set A is truthful implementable if, and now comes actually a full condition, a full if and only if. The set R, actually the key here is the geometry or the structure of the set R, the bad guys. Not the good guys, actually it's the structure of the bad guys. These are the guys that I have to kill, but without stepping into the territory of the good guys. And what has to be the case is that every connected component of R contains a cycle. Let me just explain. We talk here about trivial graph theoretical concept. The connected is by the neighbor relation. Connected means that there is a path inside the set of going from every 2 points. A component is a largest set which is connected. So a set R must be, by definition, it must be partitions uniquely into a set of connected components. Clear? So now, and the condition for the truthful implementability is that the set R, every component contains a cycle. Let me explain why. He's a bad guy. I have to kill him. So I have to guide him to something which is not a solution. Now, notice one thing which I skipped on is that if I can guide this guy to this guy, then it must be also the case that I guide him to a neighbor. Now, therefore, there must be a neighbor that is also, so I kill him by actually guiding him to here, but also I kill him, therefore I also I kill him also by guiding him to some of the neighbors, actually any neighbor which is in this direction. So there must be, so if I kill him by guiding him to a good guy, that's not good. So it must be that I guide him actually to a neighbor which is a bad guy. Now I must kill this guy as well. Now comes the assumption of the coherence. The coherence actually is equivalent in the language of the graph theory language, is equivalent to saying that if I guide A to B, I am not guiding B to A. That's actually the meaning. And therefore, now I cannot go back, and I must continue in this way. Now, everything is finite, so eventually I must go back to a point before. So this means that if there is truthful implementation, it must be that any point is connected, namely in the component that every element of R is connected, of course, in its component to a cycle of bad guys. That's the reason that this is a necessary condition for a truthful implementation. One thing probably I said too quickly, which is, I would like to repeat actually why this is impossible. This is impossible because of the requirement of truthful implementation. Because the truthful implementation, if I guide him to a good guy, the good guy is allowed to say the truth and to be accepted, to be persuasive. If it was not like that, then it could be the case that I kill a bad guy by guiding him to a good guy, because actually this good guy I would save by actually allowing him to cheat to another solution. That's clear? So that was the point actually, that crucially we use the fact that we talk about truthful implementation. Killing the bad guy by guiding him to a good guy is impossible under truthful implementation. Clear? Okay. Now, on the other end, let's say that this is a component. Let's say that this is one of the components of the bad guys, the set R. So what I have to do now is to construct the codex that will kill these guys without stepping out from the component. And of course, that's very easy because, without going back and forth. And that's very easy because if every component contains a cycle, so what I do is the following. I construct you remember we talked about is that if you have this profile is a neighbor of this profile. So there is a sentence we've said before, there is a complete sentence such that it will kill this guy and will guide him to this guy, right? So what I do now is I construct actually a graph, but the graph is translated into the codex. That's clear? Every arrow is translated, and I do it in the way that in the cycle, I do it in this way, like in the example before. And now what's about the rest? Everybody is directed going into the direction of the so I choose one, maybe there are more than one cycle. I choose one of the cycles, and then in the direction of the cycle. If I go in the direction of the cycle, then I don't go back and forth. And that's well defined. So that's a construction, that's actually a full proof that that the necessary sufficient condition is that every component of bad guys contains a cycle. Well, that's a bit probably too general. So in the paper you can find actually many conclusions from this proposition. And let me show you only one. A conclusion of this proposition, I mean something like this proposition 3, which says the following. If you have at least 3 variables, then if the set of the good guys is small, what does it mean small? Small in the sense that it does not contain more than k-1 good guys. If that's the case, always you can arrange truthful implementation. So if the set of the good guys is small, truthful implementation is fine. Now, why intuitively? Because this means that the set R is very big. If the set is very big, you can, now, what's the exact proof? The exact proof is now we imply some very simple graph theoretical arguments.
There's 2 elements, it's not possible.
It's 2, it's not. Right, exactly. So the set of if the A include not more than k-1 elements, then first of all the set R, the set of the bad guy, actually must be connected. So there is no actually component. The set itself is connected. Why? Because if you have at least k equal at least 3, then there is a famous proposition in graph theory that says take the 2 extreme points. There must be actually between every 2 points there is actually at least k paths, which k passes from the 2 points which are disjoint. So there are k passes which are disjoint, and therefore, if there are k passes that are disjoint, and there are only k-1 good guys, so it must be that one of the passes does not cross the good guys, so it contains only the bad guys. Therefore, any 2 points are connected by a path of bad guys. Now, That's number one. Number two, I claim that it must contain a cycle. Why it contains a cycle? Because if it does not contain a cycle, then take the path, that's what you see here on the right, take a path which is the longest path again, using the neighbor relationship of bad guys. So let's say that S1, S4 is the longest path. Now, if it's the longest path, now notice the following. S1, I cannot continue the path. So there is no another bad guy. There is no another bad guy who is a neighbor of S1. If it was one of the guys S3 and S4, there was a cycle. If not, then it must be how many that all the other. How many neighbors does he have? He has k neighbors. He has k neighbors, so it must be that one of the neighbors is S2. The other k minus 1 neighbors, I cannot continue the path, so they must be good guys. But now, if k is greater than 3, then this path must be at least 4. And now look at S2 and S4. There is a property again, in this graph, there is a property that if S2 is a neighbor of S3, a neighbor of S4, then there must be also another guy who is a neighbor of S2 and S4. So again, if A is a neighbor of B, neighbor of C, then it means that I made one change and I made another change. But now if I made the first change first, I get another neighbor. So therefore, there must be another neighbor, and this neighbor must be a good guy, because if it was a bad guy, there was a cycle. But now we got that we need k neighbors, k good guys, and there are only k minus 1, and therefore it means that there must be a cycle. So in any case, whether you followed it or not, it's quite a very simple graph theoretical argument that uses the basic proposition to conclude, as an example, that if the set A is small relatively, namely less equal, cardinality less equal k minus 1, then there is a truthful implementation. Again, in the paper you will find another 3 or 4 implications of the results that shows that particular sets could be truthfully implemented. Now, what's about implementation? That's much more difficult. Actually, we got almost to the solution, and then we got in hand by help from Chuck Wilson, who gave us help us in the proof in the last moment. And here is the proposition. The proposition is the following: A is implementable if and only if every connected component of R either contains a cycle. Then, if it contains a cycle, then we don't need the implementation, even truthful implementation is possible. Or, and now comes a condition that might be strange a little bit, a profile R, it must contain the component must contain a profile R such that R is a neighbor of a good guy who is a neighbor of another good guy. So again, the condition is that in any component like that, you can find, if there is no cycle, then I think about it as there is a way out. What is a way out? A way out is that I have actually a good guy who is actually a neighbor of another good guy. Why? Because, think about it, okay, think about it. Let's say that this is a component of bad guys. I cannot arrange now the truthful implementation. There is no cycle. So I must somehow encourage somebody to cheat. So let's say that so what the conditions say, I encourage him to cheat in this, or actually I kill him, so I have to kill him, and I kill him through actually allowing him or guiding him to a good guy. But now what's the problem? The problem is that I cannot have this guy being admitted, because if that's the case, then he would cheat and succeed. So I must actually allow this guy, I must save this guy, and by saving this guy, the only possibility to save him is by guiding him to another good guy who is actually a neighbor of him. That will be a solution. So that's actually, in some sense, the necessary condition. The problem, which is at least we did not find trivial at all, is somehow to show that this is also sufficient condition. And what's the problem? The problem is that, so how to do it? So how to build in the positive case. In the positive case, what I will do, this is the exit. So I will guide this to this and this to this, and everybody will go in the direction of the exit. This is well defined. What's the problem? The problem is that there is another component here that the only way to save it is by actually guiding somebody here to this guy. And to save this guy, I will need probably to go back to this guy, and that's something which I don't want. That's the difficulty. And so the difficulty is somehow to show that in spite of this difficulty, you can arrange the codex such that this will be done. So again, the condition here is you have either every component of bad guys either contains a cycle, or there is a sort of an exit in the sense that I can take one of these guys in the component, send him to some good guy who will be sent to another good guy, and this will be the trick to the device for the arrangements. Again, there are propositions, there are conclusions. For example, I will not prove it, but for example, if the set of the bad guys is very small, namely the set R contains less equal k elements, then actually this proposition is relevant and leads to. You can see it actually from the case, for example, R equal, there is only one bad guy. If there is only one bad guy, then of course you can implement it, but you must actually make him cheating, because you might actually guide him to a good guy who will be guided to somebody else. Okay. But in the paper, you will find many more examples of sets which are implemented and are not necessarily truthfully implemented. Let me just say one thing I forgot to mention. That's actually an answer to Vijay's question before. As I said, there are many other procedures that you can think about. And one of the natural procedures would be, I'm A, I'm not good. I try to be B, but B is also not good. So I move from B, the reason that B is not good, because actually he is killed and guided to C. So I go from A to B to C. So that's another procedure that one can think about, whether it's fine, ever limited or not. And actually, if you don't limit, namely, if you do allow that I will continue this process, then proposition in the paper that this type of implementation through this alternative procedure is equivalent to truthful implementation. So this paper you should not write, because this is done. But any other procedure, okay, I have a little bit more time, so let me talk a little bit about, so that's the analysis, that's the type of the analysis we do. And let me, the last 10 minutes, let me spend on just trying to, I'm not experimental guy, but this is the last 15 years I did some experiments. And this is the one experiment that I did with Kobe, which I am most proud about. It's also, we did a terrible quote unquote, mistake, which is that instead of writing a paper about it, we put it in the last section of the paper. And I don't know if anybody read the paper, but definitely nobody reads the experiment. And that's a bit pity, because I at least find, I just don't compare it with my own experimental work. That's the experiment which I like most. Okay, so here is a little experiment. I forgot to send it to you. That's pity, but now again, please relax. That's important, because you will see something terrible in a second. I should say again that the results that I will report is through my website. I mentioned it actually the other day. Okay. It's a very trivial experiment. Only 2 screens. I like very short experiments. The people are still have patience. If they are shorter than 3/4, then they lose. So here is the story. Please answer the following questions about yourself. On most days, you go to bed before midnight or after midnight. For most people, it's well defined. I know that some people would say sometimes before, sometimes after. It depends, etc., etc. But I think most of us, yes, I go after. Some people go before. Yeah, right. It's very clear. By the way, I have now a lot of information about when students of game theory go to sleep. That's very useful information. But actually, let me also tell you that actually I'm cheating here a little bit, because in one point after the beginning of the experiment, then we changed it a little bit, because most people, the big majority of people went to bed after midnight, so we changed it from midnight to 1 a.m. So, and then it was more balanced. Okay. That's question number one. Question number two is probably, you will find it very funny. Don't laugh. Which of the following do you prefer, cheesecake or chocolate cake? Now, here comes introspection of Kobe and me. It was very clear to us that everybody in the world has a very clear opinion whether it's a cheesecake or chocolate cake. I am a cheesecake, I swear. Kobe is a chocolate cake. So we have the separation. But now I know that some of you feel, what this sort of question is that? I mean, I am not cheesecake and not chocolate cake. Yes, I will explain in a second why we put it. But I think that still most of the people, even if they don't feel so strongly like me that I'm a cheesecake guy, then at least they have some sort of tendency or some preference to the cheese and not to the chocolate, or the opposite. But it's quite a good characteristic of human beings. And the third is actually a very objective question. You were born on an odd day of the month or an even day of the month. Now, why did we have to do something like that? We wanted to have properties, questions which have 0, 1, yes, no, or two possibilities. And of course, any question of yes, no has this property. Our problem was that we did not want to have questions of yes, no, because we did not want to have the negation because of the asymmetry that could actually emerge between the affirmation and the negation. And we did not want, and actually it's an interesting property of the language, that there are very few relations, unary relations, that have names both to negation, to the affirmative, to affirmation and for the negation. Are you a male? Either yes or no. For the no, there isn't a word which is a female. Now, we did not want to include that, and because, of course, because we were afraid that some people, probably especially males, will feel that even for this experiment, they will not feel comfortable to say, I'm a female. So we wanted to avoid very sensitive things like that. And then actually, we thought about it a lot. We consulted people. There are very few possibilities to have a unary relation, that the negation, it's a part of the efficiency of the language, that the negation is a name. Okay? In that case, these are the screen one. You answer these questions. I think that we assume that people don't have any reason to cheat. Maybe they, at this stage, and even if it's not cheating, then they identify with the answers that they give. And now comes the terrible things. Assume now that as a part of marketing campaigning, you have been offered the chance to participate in the lottery. The winner of the lottery will be awarded $1 million. Ha, ha, ha. Of course, there was no $1 million. It was only $100. That's one of the only experiments in my life that we really paid people. But only one person. In order to be eligible to participate, you must answer 3 questions about yourself, and your answers must not violate any of the following 6 preferences. This was because just to explain exactly what, a simple way, what does it mean. And here comes 6 propositions of the type, if you usually go to bed before midnight and you were born on an even day of the month, then you must prefer cheesecake. Okay, these are the 6. Now, this, by the way, is, I'm sorry I did not send it to you because it's much more difficult than you think. I mean, Kobe and me, we were so many times we were confused about solving these sort of questions, including actually in the end of, actually in the paper there is, in the publications there is even a typo because of some mistakes that we did in the last moment that we thought that we correct something, we corrected in the wrong way. But in any case, it's not a trivial task. Sorry, I brought it the task, and then assume that you very much want to participate in the lottery, and you know that the company has no way of verifying whether your answers are true. How would you answer the following 3 questions? And now comes the 3 questions again, the same 3 questions. Okay. That's all. That's the whole experiment. Now, surprisingly, people took it more seriously than I thought. That's good. And let me explain what's going on here. So there are 8 profiles. On the left, under T, you see the 2 profiles. It's not important what are they exactly, but these are the 2 profiles. There are 2 solutions here. By the way, this is, you can think about it as a logical equation. So 8 minus 6, there are 2 solutions here. There are 2 solutions. And now, who are these guys? These guys are the 3 guys that if they follow our procedure, then they will solve the riddle. Namely, they are guided, these 3 guys are killed, but they are guided to one of the 2 solutions. These guys are killed, but they are not guided. They are guided only to either some profile in R or to something in this set. Okay, that's clear? So if we are right, that people use this of course, we are not right or wrong because we don't think that people really use this procedure. We are not that crazy. But if you take our model very seriously, and we are not, but if you take it very seriously, then this would mean the following, that everybody here should succeed. Not only should succeed, he should succeed by declaring his own profile. Everybody here should succeed, but again, not only succeed, but succeeding by declaring the profile, the unique profile that is guided to. Is it clear again? Everything here is actually a complete profile. So it kills one profile and it's guided him to unique neighbor. Okay, so the prediction should be that everybody will succeed here and will be guided will actually say the solution that he is guided to, and everybody here should fail. Now, if this would be the result that I would report to you, you should say one thing, which is that I'm cheating. Of course, there is no any slight chance that this will be the result, because of course people don't exactly use it. Actually, not only, and even if they use it, by the way, like us, I'm sure that many of the people did mistakes. And this mistake may lead him actually to whatever. And now comes, at least to me, was a good surprise, or a good surprise in terms of the paper, not of the life, which is that, and now let's see. So here is a table that summarizes some of the results. Let me explain. You remember there are 3 types of guys. The guys who should succeed by just telling the truth. Their rate of success is 80%. These guys should succeed by cheating. Their rate of success is 54. This guy should fail. Their rate of success is 36. So the first thing, I think that this is, and by the way, the numbers are quite large here, so that's quite, I think that this is a very strong result in the direction of the procedure. But now comes something which I'm obsessed with the MRT, the median response time. We measured also the response time, and the numbers that you see here are the median response time, not of everybody, but this is the median response time of the guys here who succeeds. So we eliminate the guys who fails. So out there is about 80, 81 people, 82 people who succeeds after 104. These 82 people, the median response time is about 2 minutes. These guys, the 54% of the 180 succeeded, But look, it took them much more time. It took them more than 2.5 minutes in the median time. And these guys who should fail, the guys who succeeded, and about 100 of them succeeded, but their response time jumped to more than 5 minutes. So we did not constrain the time, but this very much goes in the direction that if we would constrain the time, so many more of these people would fail, and the same is here. So I think that's, by the way, the honest column, this is actually, we ran actually many, not many, but about 4 or 5 experiments of this type, and I think I can say that in all of them, there are about 30% of the people, of the subject here, who answered honestly. Now, why did they answer honestly? Maybe that they actually thought that the experiment is about honesty. Maybe they don't want to cheat. Some people just, as a principle, don't want to cheat. And my guess is that about 30% of the people are of this type, at least in the type of subject that we were playing with. Let me only show you one more table and conclude. This is a table where you have the 8 types. Here it's in the language of 1 and 2. It doesn't matter. The 2 translate to 0. And what you see here, these are the the guys in T. These are the guys that should succeed, and these guys, the guys who fail. What you see here is there are 29 guys who are 110 and declared 110. There are 6 guys who are 110 and succeeded, but they succeeded not by saying the truth, but actually by cheating. But they just, probably because they tried the truth and were confused and found something else. Probably they were using another procedure, absolutely possible. By the way, other procedures that I can imagine is, for example, in this case, even in some time constraints, starting with truth, true, true, and moving from there. Or indeed, just going through all the possibilities until finding a solution. Now, notice the following. So in red, what you see is, these are the honest guys. So there are many honest guys. But, and you see here, the guys in T, most of them indeed, a vast majority of them, indeed between the 2 solutions, choose the one which is the truth. Which is, again, that's what we wanted to show here is basically 2 things. Number 1, people start anchored with the truth. They could actually, in principle, these guys could start with this, or these guys could say this. But no, actually, here actually a vast majority of the guys from this class indeed declared the truth and not the other solution. Number 2, we want to show that there is a tendency, at least, to go into the correction of the consequent. And this is something that you can see very nicely here and here. Namely, here, there are 2 solutions, but actually the 111, almost everybody went to the 211. Here, again, the vast majority from 212 moved to 211. By the way, in spite of the fact that this is also a neighbor. So it's not because it's a neighbor, but because it's guided. Here, actually, regarding this, I don't know why, actually, it was 50-50. So there are many more things to say here. By the way, you can see that these guys also, these are in yellow. I forgot to mention it. In yellow, this is the yellow means that this guy is guided to this guy. So as you see, even the guys who did not succeed, then they try at least a lot the profile that they were guided to. So this is the sort of support that at least the elements, the ingredient of the procedure, there are. I would not, again, I would be careful and say that there is some evidence that the ingredients at least appear quite nicely in this very, and again, we talk about students of game theory, quite intelligent, as we know, and quite phenomenal exist. We repeated it, but let's say. Okay, finally, yeah.
Just curious, you did the experiment after you
No, before.
Oh, you did it
Before, number 1. Number 2, with all respect to ourselves, I don't think that we are so famous that after the paper people read it, and I bet, and actually I did it in several times, that in the last few years when I gave the paper, I gave to people like you to this experiment, and the results are very similar. So that's not. Well, let's keep on that now, and let me just go conclusions. Well, you know, this is the conclusion page. But if you insist, and we are not angels, and you know, when editors and referees require, so we write the nonsense that we are required. I confess these are nonsense. You don't have to read them. Probably the only thing that I can say is that this is just a story, a fable in my language. Take from it whatever you want. Of course, we did not open a consulting firm to people how to separate between good and bad people, and we are not going to do it. It's not a matter of it's just a story, and take from it whatever you want. In particular, I think that it's a demonstration of the possibility to separate by cognitive, through cognitive differences, full stop, rest. So that's actually the picture that I put at the end. Actually, I put it just because I like it. I took it in Iceland a few years ago. After exposed, actually, I thought that it could actually have a meaning here, because I don't know what's the word in English to this. Vijay, do you know the word? What is it? This? It's not the ladder, but there's a name. The idea is actually to separate between human beings and cows. So human beings can cross, and cows cannot. So that's actually what the codex does. The codex is like this ladder. It separates between the people that we want to move and the creatures that we don't want to move. I'm 4 minutes late, but let me spend 30 seconds now, just mention this guy. Now, I have some experience with him, because I know that then he will say some nonsense about me. And let me just clarify. The one person that really should get the 99.9% even of the credit for this event is Inku. I'm his assistant. I'm really his assistant. And there is a big, my experience in life, there is a huge difference between being the director and being in charge and being assistant. It's very easy to be assistant. It's very difficult to be a commander. And Inku, for the last 6 years, it's his initiative. And he's in better days and worse days, he's fighting to keep having it, as you know, from what you got as travel guns and so on. It's probably the cheapest summer school in the world. The budget is extremely small, and it's not based on any corporations that support it, or even the Economic Society basically gives the name and $3,000 or something like that. So it's really based on completely volunteering of the lecturers and especially the work of Inku. So I guess all of us want to thank him for. And thank you for coming.
That concludes this year's summer school.
Oh, so I forgot one thing. Sorry, I brought. Some of you know that I'm obsessed with cafes. So first of all, if you know about cafes in your city that you think that really are good for thinking, not for coffee, please send me. And I have also 4 posters. So if tubes with posters, 4 of you really want it, can get it. I sorry I did not bring more, but.